Newton's first law versus Newton's second law of motion. Understanding fundamental principles. Newton's laws of motion are foundational principles in classical mechanics that describe the behavior of objects in response to forces and their interactions. Newton's first and second laws of motion outline fundamental concepts concerning inertia, force, and acceleration, providing insights into how objects move and interact in the physical world. 1. Newton's first law of motion, law of inertia. Newton's first law states that an object at rest will remain at rest, and an object in motion will continue moving at a constant velocity unless acted upon by an external force. This law introduces the concept of inertia, which is the tendency of objects to resist changes in their state of motion. 2. Inertia. Inertia is a property of matter where objects with more mass have greater inertia, making them more resistant to changes in motion. It explains why heavier objects require more force to accelerate or decelerate compared to lighter objects. 3. Practical example. For example, a book resting on a table remains stationary until a force, such as a push or pull, is applied to move it. Once in motion, the book continues moving at a constant speed in a straight line unless another force, like friction or gravity, acts upon it. 4. Newton's second law of motion. Newton's second law relates the net force acting on an object to its mass and acceleration. It states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. 5. Acceleration. According to Newton's second law, if the net force acting on an object is increased, its acceleration also increases, assuming mass remains constant. Conversely, if the mass of the object increases, more force is required to achieve the same acceleration. 6. Practical example. For instance, pushing a car requires more force to accelerate it compared to pushing a bicycle because the car has a greater mass. This illustrates how mass affects the amount of force needed to produce a given acceleration, as described by Newton's second law. 7. Relationship. Newton's first law describes the behavior of objects in the absence of external forces, emphasizing inertia and the tendency of objects to maintain their state of motion. In contrast, Newton's second law explains how forces cause changes in motion, quantifying the relationship between force, mass, and acceleration in dynamic systems. 8. Applications. Newton's laws of motion are fundamental in physics, engineering, and various scientific disciplines for analyzing and predicting the behavior of objects under the influence of forces. They provide a framework for understanding mechanical systems, designing technologies, and calculating the effects of forces on motion. Conclusion. Newton's first and second laws of motion are fundamental principles in classical mechanics that describe how objects move and interact under the influence of forces. Newton's first law introduces the concept of inertia, stating that objects at rest remain at rest and objects in motion continue moving unless acted upon by forces. Newton's second law relates the net force applied to an object to its mass and acceleration, quantifying how forces cause changes in motion. Understanding these laws is essential for analyzing motion, calculating forces, and applying principles of mechanics in scientific, engineering, and everyday contexts.